Hi all, I thought I'd take you out into the shop here and show you what's going on as I move forward with modifying the wingtip panels to extend the elevons. What I've set up here is a little mock-up, little model where I can analyze the motion of the ends of the elevons and make sure that I don't have any binding in the system. I have to do this because there's a change in dihedral of the wing. The inboard wing essentially has 0 dihedral and the wingtips have 5 degrees. So what we have here, if I can point this out, these two ribs here represent the ends of the elevons. This is the tip end of the inboard elevon. This would be the root end of the wingtip panel elevon. And I wanted to keep the drive system as simple as possible. Helps prevent failures that way. Simple is always better if you can do it. So nominally, I'd get on SolidWorks and just model this up and do a motion study, but as you know, my license for SolidWorks is in limbo. So we just build the actual model. This stick here, dowel here, represents the axis of rotation for the inboard elevon, and this one out here represents the axis of rotation for the elevon on the wingtip panel. And the third stick here is the drive mechanism, bonded to the inboard elevon and slips into a hole in the tip elevon, so that when the wingtip panels get mounted onto the main panels, it will just slip over this drive here, so that when this elevon goes up and down, it moves the other one up and down, just like that. And I have this set up so that this axis is horizontal, just like the inboard panel, and the other one is angled up at 5 degrees. And of course, when you're angled up at 5 degrees, as you move up like this, the tip elevon is going to tilt in towards the main wing panel, and that's because it's at a 5-degree angle. So we have to accommodate that motion. So as this rotates up and down like this, and it's only going to go 30 degrees from about there to there, something like that. But the idea is that the connecting drive rod is free to float in this hole. It'll slide in and out. So as this comes up higher, it'll be tilted towards the inboard panel, and it'll just slide on that dowel. And I'll provide a hard point on the end rib there. I'll put a couple of rings of carbon fiber around that hole, and then I'll probably fit a piece of Delrin plastic on the inside so that it has a nice slippery surface to run on. So that's the current plan for extending the elevons and how to drive them. I can't use control horns like I did on the temporary setup because they interfere with the transportation setup in the trailer. And this will all be enclosed, this drive mechanism be enclosed inside of the winglet mount, so it doesn't add any extra drag to the wing. So that's how we're taking care of the driving the elevons overall. In the long term, I'm going to have to modify the inboard panels because right now the drive for the elevons is at the root end of the elevons. And with this extension, there'll be a tremendous amount of torque in the system, especially at higher speed maneuvering. And it's probably more than the little D-tubes on the elevons can withstand. So I'm going to have to move the drive out to the middle of the overall elevon, which would mean that it has to move out far enough so that it's somewhere in the outboard 1/3 of the inboard elevon. That'll be somewhere in the middle of the whole shooting match. So that'll be a major modification this winter. I'll have to open up the main wing panels, build hard points for bell cranks, and probably put in push rods at that point, get rid of the cables and put in push rods. So probably a major modification coming up this winter before we could move on to any higher speed testing. With this setup, I'll be able to get the testing done at El Mirage we'll be able to take it up, couple 300 feet and do a little bit of maneuvering and keep the speeds low, and this will work fine. So here's a shot of what I did yesterday. I mounted the tip panels to the main panels and marked out the hinge line for the extended Elevon. And you'll see that it comes out very close to the spar out here at the tip. And I have enough room before the spar. I can fit the whole hinge mechanism inside here. So I'm just going to run it all the way out to where the solid wingtip is. This rib will stay on right here, and I'll have to make a sub rib in here for the Elevon. So that gives us a highly reverse taper Elevon, very wide out here at the tip, which is good. Now, of course, the temporary ones I had were tacked onto the trailing edge here, and the glider got quite pitch sensitive, and I reduced the throw to deal with that. This is moving the centroid of the extended Elevons for the preliminary test was way back here. Now it's going to be up in here. That's, a foot and a half of change. Let's see. Yeah, it's a little more than a foot and a quarter. So that'll have a significant impact on the pitching moment. This will reduce it. Now the area is larger. That will increase it. So it might be a push. It might be a little less pitch sensitive this way. If the pitch sensitivity goes down, then I can always just increase the throw quite easily to one setting change on the mixer, and I can move that back and forth. So what we have is an Elevon shape now that runs very close to the spar. This is really close to what was done on the Pranal M, the man-carrying Pranal wing. And I'm going to have some other information coming at you that we did some testing last Saturday. In addition to the whole glider, I tested different Elevon shapes, and we discovered some phenomena that's occurring with this when you have an Elevon with this significant reverse taper where the tips are very wide. It's very beneficial to the flow conditions on the wingtip in terms of helping prevent tip stall and helping increase the proverse yaw. And I'll have a video coming up to discuss technically how that actually happens. And I am working on providing commentary for all of the video that was shot on Saturday. There's quite a bit of it, and that'll be coming later. So I thought I'd just do these short little videos to bring you up to date on the daily progress here. I'm trying to get this ready inside of the next 2 or 3 weeks so we can get it down to El Mirage and do some towing with it. So fly safe. Bye for now.